Hello, innovators. Welcome to the Bridging the Gap podcast. You're invited to join my mission to embrace and share the innovations transforming the AEC, MEP, and manufacturing industries. My guest today is the Senior Product Manager for AEC Generative Design at Autodesk. She's an architect with a passion for re-envisioning the way that buildings are designed. After working for several years as an architect, she joined Revit Technology as a fledgling startup where she helped grow it to where it is today in almost every architect's toolbox. She has gone on to work on many Autodesk tools, including Formit, Dynamo, Project Fractal, and Project Refinery, which has just graduated from beta. Welcome to the show, Lilli Smith.
Thanks.
I'm very excited to talk to you all about generative design.
Great.
So let's start off kind of setting the terms. How would you define generative design?
So that is a good question and causes a lot of people are asking that in the industry. And I think the way that we are defining generative design, generative workflows, and I like to call it kind of generative design with a lowercase g and a lowercase d, is really about a workflow. And it's about a workflow that uses data and computers to help you generate a lot of options that you can then analyze and compare against each other. So it's really about, the generation part is the computer is helping you generate options. It can be a little bit misleading to some people because it's not coming up with those options itself, right? The computer is not generating these designs out of the blue. It's definitely based on the models that you describe and the inputs that you are giving it to and the geometry parameters that you're giving it to make these models.
Gotcha. It's not a magic button designed to wipe the architect out.
It is not a magic button. No, it is something that architects really, I think, should learn about and partner with to enhance their design workflows.
Gotcha. How did you first get interested in all things generative design?
Yeah, so the problem of how can we design better buildings has really been a question that has guided my career. So as you were saying in the intro, I started out working on Revit when it was a startup because I thought what they were trying to do with 3D building information modeling was really a big improvement over what was available at the time with 2D computer-aided drafting. And after we were bought by Autodesk, I kept working on Revit, and it was really, a thrill to see it adopted by so many architects.
Yeah.
And after a couple of years of that, I was really psyched to work on some of the first energy analysis tools in Revit. It was like in 2007, I don't know if you remember like Al Gore's movie that came out, The Inconvenient Truth, which really spurred a lot of people into action around what are we going to do about climate change. And so I was really psyched to be able to work on kind of next generation tools, looking at how can we automate the creation of energy analysis or models from building information models that were appropriate and good to use in hourly energy simulations, which would give you data about the at an early stage when you can really make changes about what your model was, or what your energy use was going to be. But the thing with that was that we had this great process to create automatically these energy models, but it was really a one-off, right? Like you would design the mass, the form of your building, and test it. But there was no way to automate, like, what if I turned it 5 degrees and tested it each, each iteration of that, or if I had different parameters for its ratio of length and width, and I wanted to test all of those things. I could do that manually, but what computers are really good at doing kind of rote perhaps boring work, like those minute
Yeah. Well, how do you optimize
manipulations.
it better? How do you optimize that process better?
Exactly. And yeah, how can you use optimization also to help you think through those various options? So around the same time, Autodesk Research was also doing some studies around generative design. So Autodesk Research actually bought this architecture firm called The Living, and they were working out of New York City, and they were really interested in applying some of these concepts of generative design, because it wasn't, this is not a new thing. Like, generative design has been in art and architecture for decades. But they were really interested in seeing, okay, how can we use the concept of these workflows and apply them to real projects? And so they did some really successful projects on redesigning one of our Autodesk offices in Toronto, and also redesigning the entire show floor at AU 2018.
Oh, wow.
Or sorry, AU 2017. And then those ideas, our customers were like, we really want to be able to do that too. How do we do that?
Yeah.
So that was how we really kind of got the energy in the company and the money in the company to invest in making some of these technologies available for more people to try them. And because that's, what Autodesk is really has been founded on, is bringing these technologies to a lot of people.
Oh, sure. Nice.
So,
so you've been working on some next gen solutions at Autodesk for a while. What's been one of the biggest changes that you've seen in that time?
The biggest changes in how we make technology, or?
Sure. Yeah. Just to the technology landscape. What's 10 years in technology? That's like 100 years. Has there been some sort of kind of big moment that you would be like, oh, wow, that's when things really changed in the last 10 years?
Well, a couple things. I mean, architecture and adoption of technology actually takes a long time. I mean, a lot of people are still using 2D CAD, and a lot of people are using 3D building information modeling, but it's been like 10 years moving towards just adopting that technology. So it actually moves slower than technology in a lot of places. But things like things like the cloud have had a huge effect. We were in the current climate of this pandemic and working from home. Autodesk really invested several years ago in sharing technologies using the cloud, and investing in making that secure and making it work well, so that people could work from, we already had the problem before of people working between different offices.
Sure.
And it turns out that now, when they're all working from home, that technology is really helping them to stay, productive in these projects that they're doing. Right.
Yeah. No, that's great. So why do you think generative design hasn't been as embraced as quickly? Or maybe back to your point of it takes a while for technology adoption to really go into place. Why do you think the generative design part of it has been just not as widely embraced across the industry?
Yeah, well, I mean, we've been in beta projects. We started with Project Fractal 4 years ago. Okay. And then we kind of took a little different tact, because we wanted to make a tool that worked better with Revit, which is on the desktop, and also took advantage of a lot of the community work around the Dynamo Package Manager for people to share little bits of code.
Mhm.
So we took a different tact with Project Refinery and made it work locally. And that we have just graduated that now into Revit 2021 as a tool that's really widely available to people. So it hasn't, it's been available in a public beta for a couple of years, but getting it out, we joke that the best software tool that there is really is an installer, right? Because if you give people like a huge list of instructions about how to install this beta, it can be really a barrier to getting them going with it, right? Like,
sure, it's intimidating
after step 4. But now we have the opportunity that we actually have it installed with Revit 2021. So you don't have to do anything now to start experimenting with these tools.
Yeah, that's awesome. What have you seen as the response so far with the big announcement that it's in Revit 2021?
It's been, I think a lot of people the concept is actually, while it's been in the industry for a long time, the concept of actually being able to do this is new to a lot of people. So, we've seen a huge spike in use though already, which would be expected because it's just such a larger audience that we can, we have.
Sure.
And people are interested in trying out these new tools. So, time will tell and see how sticky they are. And, and we ship with some sample content that people that are Revit users and not coders themselves can get started with.
Okay, nice.
But really to conduct generative workflows that are useful to what your projects are and how your firm designs buildings, you need to invest in making or tweaking our scripts to do what your special design secrets are.
Yeah, to customize it more.
Yeah.
Got it. So you mentioned this a little bit earlier. What should the partnership between the architect and generative design look like?
Yeah, so I think a lot of people are scared that they think that the computer automation is going to come in and take over their jobs. But that is, it's really, there's a lot of work and really a change of mindset that designers need to do to take advantage of these technologies because, just sitting down with a team and thinking about, okay, what are our goals for this design? What are we going to study in terms of what's going to be like, what are our design variables going to be? Are we going to look at this change in massing proportions? Is that going to make a difference? And how are we going to measure how effective these different resulting forms are? Just sitting down and having that conversation with a diverse group of people who have input to the project can be a really good exercise. And there are things that should not be done with a generative workflow. Like it's not worth it to do all workflows this way, right? But there are some that really are, that by studying these slight changes or even big changes, but that have a lot of bang for your buck, that like changing things a little bit could mean a huge cost savings. It can be really worth it to use the computer to help you study more generations.
Yeah, that's interesting. Are there certain kind of best use cases that you see for generative design where you get that bigger bang for your buck?
Yeah, so we've worked with people. One of the ones that comes to mind is some people in the Netherlands who were looking at laying out shipyards, and it had a big effect for them where they located those shipyards or sorry, I really like docks, like dry docks, like places to fix ships. So they're making, but they're looking at various places along a coastline and the implications of where they would have to kind of move more dirt or, fill in some of that land to make their docks can have millions of dollars of implications. Making roadways and curving them certain ways can make a big difference. Architectural use cases like looking at reducing the number of different panels you have to create, a irregular form can be a really worthwhile endeavor to study. And it can also mean that, if you invest in making a script like that, it can be used over and over again. So I would say like that is the other place where it can really make sense. We see people in one firm in Hong Kong was doing a ton of donut-shaped office layouts. And so they invested in scripts that would help them to study those kinds of layouts because they were doing it over and over again on many different kinds of buildings.
Interesting. So look for those repeatable plays.
Yeah. Repeatable plays or plays with big money implications, big design implications involved.
Interesting. How much coding is needed to effectively run generative design well?
Yeah, so it really depends on what you want to do, right? Like we are working to provide out-of-the-box scripts that can be used by kind of any Revit user without having to necessarily invest in learning Dynamo. And if you want to do what we have programmed, or the goals in the sample set happen to match your goals, and that will that can work for you. Our newer scripts let you automatically study layout patterns, like grid patterns. You can use those for lights or sprinklers or smoke detectors and measure kind of how effective their placement is. But you'll probably want to make modifications or add goals or change a little bit how they work. And so, the other part of this strategy to make this a very open-ended backend is to use Dynamo, which is a visual scripting language. And the intent of Dynamo is to make it easier for architects and engineers to program geometry, program measuring the effectiveness of that geometry in certain cases. And you don't have to be a coder. If you are willing to learn how to kind of put these little blocks together with wires that will, it's a little piece of functionality that hooks up to another piece of functionality, and you can string things together in an easier way. There's no compiling of code. You just hook them together and then run it.
Interesting.
Yeah, and there's also a big Dynamo community that answers questions on the forum. The Dynamo forum is very active.
Nice.
And it also, they also share scripts, what I was mentioning on the Dynamo package manager, where people are sharing code and using that to make their solutions faster.
Awesome. So I'm curious, with you being an architect, does generative design turn the architect, kind of known for being the creative, does it turn an architect more into the rule-based programmer?
Well, I think you can think creatively about how you are designing this generative study, right? Like you have to, there's a lot of thought that goes into designing the automated workflow, right? Like it has to, what are the bounds of that workflow? Like how much are you going to allow your building to stretch in a certain dimension in width or in length, or, you know, what pattern are you going to start with to test these different automated layouts with? And so I think a lot of the skills that designers have with, you know, conceptualizing, you know, doing also starting with a partee can be a very important thing. So for the Toronto office layout, they started with like 6 different ideas of partees of how they wanted to lay out this office. And then within each of those partees, they studied how it can flex, how it can vary, and then they were able to measure the partees kind of against each other and against, you know, make the optimum one in each partee. So I mean, I think there's still a lot of, for sure, you know, skills that are applicable to new generative design mindset thinking, but still a lot of skills that designers have that are still, you know, very important parts of design that the computer can just then augment and let you study a lot more than you could manually. Yeah,
I think that's really interesting because it's not taking the creativity away. It's kind of shifting it and kind of adding a whole new dimension, an element to it to let your creativity kind of go to new bounds, which is, I think, pretty exciting.
Yeah, I think it's very exciting.
Nice. What are some lessons learned from Project Refinery?
So with Project Refinery, I was mentioning, so we started with Project Fractal, and that was a tool that was running in the cloud. We had basically Dynamo instances that you could run scripts with that were running in the cloud. And people really liked the sharing aspects of that. So being able to send you a link and say, hey, look at this study that I did, was a really great convenience. But as I was mentioning, people also wanted to work a lot more closely with Revit, and they wanted to leverage this really strong Dynamo community of shared scripts that they wanted to use. So our team was working on Fractal. We took a little break, and then we came back and we decided to take a different tact for a while and bring everything local. In a way that we can return to the cloud, certainly in the future, because doing, you know, right now we run on your desktop 6 instances of Dynamo in the background, and we're in order to, you know, speed up the process of making these different designs.
Gotcha.
But, you know, that is a functionality that is very ripe to, you know, return to the cloud, where you could offload that from your computer, you know, not have, while your computer right now has a lot of power, especially computers that people are using for Revit, you know, it might be nice to also be able to do that in the cloud, and then also be able to share those scripts. So we, you know, have these projects, these beta projects, because we want to get feedback from our users. So we, you know, learned that we should try this other tactic, and it was pretty successful and allowed us to graduate Project Refinery into a tool that is now part of Revit 2021.
Awesome.
Yeah, and we're still learning, you know, I mean, this is like our first go at having this out there, and we're definitely still learning from our customers, doing user testing on new features that we're building, and gathering feedback from people. So yeah, we're definitely still learning and still working on improving things. So yeah, it's exciting.
That's awesome. So there can be a lot of results that come back when you run generative design. How do you not get overwhelmed by all the options?
Right. So it's very important to work on declaring your goals, right? And use that as a guiding factor. And one of the one of the benefits of this kind of tool is that, in architecture and engineering workflows, there are, we call it multi-variable optimization, right? There's more than one factor that is changing and more than one factor that you are evaluating, because there's a lot of different factors that you would consider when you're making a building. And it's not that we're going to have all of the factors are going to be able to factor into this, but it's important what you choose and then how you measure it. And we try to make tools that can allow you to filter down the number of options that you're seeing to just certain ranges. And you can do that after the fact, so that if you, maybe you don't know what exactly, you have some idea of what your goals are because you had to set those up as outputs in the study, but maybe you don't know exactly what you're looking for. You can do a random search through the design space that you've set up. And then after the fact, you can go and say, okay, I really want to look at the, in the massing example, I want to look at all the short buildings, all the short forms, and I want to see how they perform with this other parameter. Or I want to look at all the tall ones. So just being able to rank them and filter them on different criteria that you're measuring can be a really helpful way to look through the results. We also use optimization. So we have a couple different methods in our generation, how we generate designs, right? Okay. So there's things that can do this random search, but there's also a method where you can set up what your goals are beforehand and say, okay, I want to maximize the height of this tower. So only the ones that are the tallest ones are going to then be returned to your study. And so you can, in that way, you can get the computer to help you on generation after generation of studies that it's running, return only the ones that satisfy the goals that you set beforehand. So that's another way that you can do this, filtering down of all of the designs that are in your design space. Because depending on how many input variables you have, and also what the ranges are and how many tests you're doing with each range, the numbers can get very big very fast for how many designs you're looking at.
Sure. Yeah. So it sounds like while you can filter on the back end, the more you can do kind of upfront and get organized, get your goals in line, the better. Yes.
I would say that, just having that conversation with your team about what's important and what you're going to look at studying. In some cases you can kind of like stop right there, but using, using the computer to then automate that conversation can really be valuable.
Yeah, I love it. I think anything that gets you closer and better at collaborating and communication with across teams is awesome. It's very much needed.
Right. And we think that having this data and these sets of designs that you can then filter through, we see people having much better conversations with their stakeholders because they have this data and they can say, okay, let's look at if these things are the best, or if, let's look, my tall building example, like let's look at all the short squat solutions next to and then let's look at the tall solutions. And you can see the data that is resulting from each of those solutions. It can be helpful. Or they could say, no, I don't, let's not measure this on just square footage. I also care about the how much surface area there is, or it's going to be a really expensive facade material. So actually, can you minimize how much surface area these designs are? Because that is really important. So just having that conversation can get out what goals are important for your stakeholders too.
Yeah. Interesting. What's one misconception that people have around generative design that you'd love to knock down?
Well, so we talked about how people think it's going to take the place of the architect. And I definitely don't think that is true. I think architects and designers, engineers need to learn how to use tools like this to augment their workflows. Another misconception is that a lot of people think that it's magic, that the computer is going to somehow do this for you automatically. But
I mean, it's not your fairy godmother.
Computers are really dumb. Like, they only do exactly what you tell them. So you are like right now, maybe, in the future we'll start being able to use, machine learning or some kind of AI to help us to make these scripts in an easier way. But, machine learning is also only learning from examples that it had in the past, right?
Right.
Like, it's, so garbage in, garbage out, right?
Sure.
And then I would just say that not all design problems lend themselves to generative workflow. You really have to be able to identify what you want to vary and how you're going to measure success, but also ask yourself, is it worth it to invest in writing a script if I don't have one that works on this problem?
Yeah, interesting. Well, my last question for you, what are you most excited about the possibilities of generative design?
So, given the challenges that we are facing right now with this crazy new world, this pandemic, I am extra glad that we decided to go with a very open approach to our generative design tools. So, for example, we ship with, one of our examples that we ship with is this office layout script. And when we were making this script, a couple months ago, it was assumed that the goals for office layout would always be, how could you efficiently, pack as many desks into a room, right? But
how things change.
How things change, and who knew we were going to need something really different. Assumptions change, and so it's really important to have tools that can change with the world, right? And it isn't the kind of thing that you can just build into input parameters, knowing all those input parameters before the world changed in a crazy way. But we're going to have a lot of work to do in the next few years, next several years. Autodesk and, the world projects that in 2050, there's going to be 10 billion people on the earth. And if we're going to build enough buildings to accommodate all of those people, not kill the earth, and be able to keep everybody healthy, we are going to absolutely have to use automation to help us do that work, and be able to design and build safe and carbon neutral buildings
Sure.
for the way forward.
Yeah, no, that's awesome. That's a great point to end on there. Thank you so much for coming. Really enjoyed unpacking all things generative design with you.
Yeah, thanks a lot for having me. I really appreciate the opportunity.
Of course. And thank you to all those listening. If you are interested in learning any more, you can visit our sponsor, Applied Software, at asti.com for more information. You can listen to this podcast anywhere by simply going to Apple Podcasts, Spotify, or wherever you listen to podcasts. Also, be sure to check out our website, bridgingthegappod.com. Until next time, I'm Todd Wyant, thanking you for joining us on the Bridging the Gap podcast. Keep innovating.